Hello, I'm Angela.
Hi, I am Andre.
Today, we'll be doing an experiment called Gravity Water Cup Drop.
Thank you, gravity, for keeping us grounded.
But first, what is gravity?
Gravity is a force exerted by all objects with mass, which causes them to be attracted to each other.
What are we waiting for? Let's get started.
The equipments we're gonna need includes
Plastic cups, pen, water, and a container.
we recommend you to use safety goggles and an apron to protect from spills and splashes.
First step is to gently poke a hole in the side of your cup, near the bottom. Like this.
For the next step, simply take the cup and cover the hole we made with your finger and fill the cup with water. Remember to cover the hole we made in the cup.
The first test in our experiment is to hold the cup over a container and remove your finger from the hole.
When your finger has been removed from the hole, you'll notice that the water will begin to pour out of the hole into your container.
The second test of our experiment is to hold your cup of water over a container with your finger covering the hole and drop it.
The cup fell really quickly.
No worries. Let's watch it again, but this time in slow motion. If you watch carefully, you'll notice that the water in the cup doesn't pour out of the hole as it falls.
Let's look at the experiment a little closer. Gravity is a phenomenon by which all things with mass are brought towards each other. Without gravity, we wouldn't be standing on the ground but instead floating into space. Gravity is the most accurately described as a consequence of the curvature of space-time caused by an uneven distribution of mass energy. But it is a pretty difficult and confusing description.
So, for this experiment, we will be using a description from Newton's law of universal gravitation, which describes gravity as a force where two objects with mass are drawn or attract to one another,
where the amount of the attractive force is proportional to the mass of the objects decreases the further away the objects are from one another.
Now that we have that over with, let's look at our first trial of experiment. We hold the cup in our hand and we remove our finger from covering the hole. The water pours out of the hole. This is because gravity wants to pull the cup and its water towards the earth. Our hands are strong enough to resist gravity's pull on the cup. But since there is a hole in the cup and if nothing is holding the water, gravity will pull the water through the hole in the cup because it's the easiest path to the ground, accelerating it downwards towards the earth.
At the second experiment, we dropped the cup at the same time as removing our finger from the hole. But as you can see earlier, the water did not pour out of the hole while the cup fell to the ground. Why is that when we drop the cup, gravity pulls on both the cup and the water at the same time, accelerating both of them towards the ground at the same rate and causing them to land at the same time? Because they fall at the same rate, the water is already taking the easiest path to the ground and it doesn't get a chance to pour out of the hole.